Hello everybody, welcome back to another AP Calculus AB and BC video. This is Unit 6, Lesson 3, Summation Notation. And we're going to be looking at the practice section of Flip Math's lesson. Okay, so this lesson is probably one of the hardest ones in Unit 6. But once you start to understand the concept, it makes sense, right? So I'm going to write the formula real quick. And as a reminder, so limit as n approaches infinity, and then you have k equals 1, and then n rectangles. And then you have b minus a over n times f of a plus b minus a over nk. Okay? That is the definite integral as a summation notation. Alright, let's get started. So question 1, we're given the lower limit for the first 3 questions, so that makes our lives pretty easy. So integral, our lower limit is a, right? So down here, lower limit. And remember, using the formula that I wrote, we can find what our b is. So this part is equal to b minus a over n. So we're going to solve for b doing this. So b minus a equals pi, right? And so our a is given as 0. So b minus 0 equals pi. So b equals pi. All right. And now we're going to write the inside of the integral, or the integrand. So we have cosine, so we write cosine. And this part in here is just going to be x. So dx. Next question. Integral, lower limit, -3. So b minus a equals 5. Equals 5. A is -3. So b plus 3 equals 5. So b equals 2. Right? 2 minus -3 equals 5. Next, we're going to write the integrand. So we have cube root, and then everything inside here is x, with respect to x. Next question, we have lower limit of 6. 6, b minus a equals 9. B minus 6 equals 9, so b equals 15. And then again, this is our whole function, so 1 over, and then this part right here is our x squared, right, because there's a 2. So that part was pretty simple. Okay. Questions 4 to 6, we're given the function, and now we have to turn that into a definite integral. So remember that limit as n approaches infinity of sum with n rectangles and k equals 1 of f of a of 1 over b minus, of b minus a over n times f of a plus b minus a over n times k. And then that is going to give us our definite integral. So let's write what we know. We know that a equals -3, our lower limit, and b equals 3. So limit as n approaches infinity of the sum n rectangles at k equals 1. So b minus a over n, right? B is 3, a is -3. So 3 minus -3 is 6, and then over n times f of a, so -3, plus b minus a over n times k. And then, remember, because this is x squared, we're going to square that quantity. And it's as simple as that. Next question. So, limit as n approaches infinity. So let's write our a and our b. So a equals 2, b equals 5. So, sum of n rectangles, k equals 1, f of a. So, before we do f of a, we have to do b minus a over n. So b minus a is 3 over n. So f of a is going to be 2 plus b minus a over n times k. And there we go. Why did I write it as a fraction? Well, the f of a plus b minus a over nk, that is your x. And in the original, we have our x in the denominator. So we keep the 1 in the numerator and rewrite x as f of a plus b minus a over nk. Next one, we have a equals 0, b equals 7. Limit as n approaches infinity. Okay, so we have sum of n rectangles, k equals 1. b minus a over n. 7 minus 0 is 7 over n. Times, we're going to do square root. b minus a, f of a, so f of a is 0, plus b minus a over n, k. So b minus a over n is 7 over n times k. And that's your answer. So, again, not too bad once you understand the concept. Alright, next question we have is which of the following expressions is equal to limit as n approaches infinity of 1 over n, and then we have e to the 1 plus n over n. Alright, so what do we know? b minus a is equal to 1. So b minus a equals 1. So what can we do? We can eliminate d automatically because 2 minus 0 is 2, not 1. Alright, well, let's take f of x as e to the x. And if that doesn't work, we'll try e to the 1 plus x. So e to the x, if we're going to do f of a plus b minus n, okay, we're going to, okay, so we could try a or b first. So let's try a. F of a is, okay, so 0, right? So e to the 0 is going to be 1. So we know that that doesn't work, right? We write the rest, f of a plus b minus a over n. So plus 1 over n. So we have the 1 over n part, but it's e to the 1, not e to the 0. So let's eliminate that. Now, let's take b. What is our a for answer choice B? Our lower limit a is 1. So f of a plus b minus a over n, which is right here, 1 over n, plus 1 over n. Well, that matches with the first term that's given. That matches right here. And so this is our answer. But let's check C. Let's check C. So C is given as e to the x plus 1. So let's take the lower limit. Let's take the lower limit. So lower limit for C is a, which is equal to 1. So when you use lower limit, we get e to the 1 plus 1 plus, and then that stays, right? b minus a over n, because 2 minus 1 is still 1. So we get e to the 2 plus 1 over n. That doesn't match any of these. And so our answer has to be B. Okay, the expression 3 over 7 and then the following is a Riemann sum approximation of which of the following integrals? Okay, so unlike the last question, there is no limit as n approaches infinity. So the only thing we can do is look at the pattern that we have. So I noticed that so you have a constant, you have a number times sine of that same number. So right off the bat, it's looking like A or B because we have x and then sine of that same x, right? As C and D only have sine x, but in the expression, we have a number, that same number in front, like as a coefficient. So we can eliminate C and D. Now, remember that this part right here is B minus A over N. That is B minus A over N. And so we have N rectangles, so we have 7 rectangles. And so we ignore that, however, because, so we're going to ignore the 7 because it has nothing to do with the function. What's changing is the x and the sine x. So we can eliminate B as 1/7 has nothing to do with the function. And so I hope that makes sense. Okay. The expression 1/5 times ln of blah 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 is the Riemann sum approximation of which of the following integrals. So similar to last question, we're gonna do some elimination. So 1/5 is B minus A over N. So we know that B minus A equals 1. So off the bat, we can eliminate B because 5 minus 0 is not 1. We can eliminate E. Alright. What else can we eliminate? Well, I think we can eliminate A because we have x over 5, but that doesn't really match any of the expression we have. Right? If you plug in f of A, so we know that A is 2, right? So if you plug in 2 for f of A, you get 2 over 5, but we get 2 in the expression as f of A. So it can't be A. And then we're left with 1/5 and then the D, which is the same thing, just without the 1/5. Well, if you remember from last problem, this 1/5 doesn't really mean anything to this expression. We just know that there are 5 rectangles, and so that's not part of the ln function. That's not part of the integral. So we can cross out C, and we get D as our answer. All right. Last problem we have, which of the following definite integrals are equal to limit as n approaches infinity of sum of n, k equals 1, negative 1 plus 4k over n squared times 4 over n. All right, so we know b minus a over n equals 4 over n. So b minus a equals 4. So let's look at all the answer choices and see if any of them don't equal to 4. First one, 3 minus negative 1 is 4. That works. 4 minus 0. Okay, that works. And then we have 1 minus 0. But we do have a 4 as the coefficient, so I'm not going to rule that out just yet. Alright, so we know for one of the answer choices, a equals -1. So that works for the first one. And then all of this is going to be x squared. So that works for 1. So 1 definitely works. So now we're going to try to verify 2 and 3. So 2 has the upper limit as 4 and lower limit of 0. So essentially, it's basically the same thing as 1. We just have a shift. We have a shift with the -1. One way you can think about 2 and 1 being the same is think of them as a transformation. So remember that if you have x minus 1, that is a shift. If x minus 1 is in a parentheses, you have a shift to the right by 1 unit. And if you look at the limits, they are shifting. They have an increase of 1 unit. And so 2 also works. So let's look at the last one, which is probably the most confusing one. So let's write the sum. So we have 1 and 0 as our limits. So b minus a is going to be 1 over n. So we have 1 over n. Then we have times 4, right? We had a 4 here. And now we're going to write again -1 plus 4. Then x, remember that x is going to be a plus b minus a over nk. So a here is 0. So we have 0 plus b minus a over n. And then, well, we ignore the k here. Okay. And in parentheses, now remember that this whole quantity is squared, right? So now I'm going to distribute this 4. So 1 over n times 4 is 4 over n. And -1. And then plus. And then 0 plus 1 over n is 1 over n. 4 times 1 over n is 4 over n. So 4 over n squared. And then I forgot to write the k. But yeah, so this right here matches up with this right here. And so we can see that all 3 answers are valid. So I hope that wasn't too confusing. I did my best to try and make a little bit of sense of it. If you have any doubts, please let me know. And with that being said, take care and I'll see you for the next lesson. Bye.